Hello friends, this is Prashant Kumar and welcome to my presentation. Today we are going to discuss what, how and why of performance testing. So let's go. So before I start, what is performance testing? As a part of testing we know we ensure that our application or system is performing the way it is intended to. And testing is divided mainly into two branches. One is functional testing, wherein we ensure the business specific requirements are incorporated and working fine. The other part is non functional testing. Non functional testing ensures user is having a good user experience and system is having a nice performance while it is working. So, what is performance testing? Coming back to this question, performance testing is a non functional testing that determines the system performance, that is, responsiveness. Quality responsiveness we can define as the quality of reacting quickly and positively, or stability, how stable your system is under different kind of load conditions. Reliability, how reliable is your system and without breaking down, how long can it work? Scalability, when we say scalability, is the capability or capacity of a system to support different loads, transaction, data volumes, etc., without breaking down under a particular workload. So, as a part of this performance testing, we try to determine different kind of features and qualities such as responsiveness, stability, reliability, and scalability of a system. It can be measured as a part of CPU speed or response time, throughput, resource usage. These are the several factors which are used to determine these qualities. Why to conduct performance testing? Now, coming to the question, why we need to do performance testing? Let's assume that you're working on a website, you are doing some business transactions, and you find the system or the website is pretty slow, and whenever you're trying to do a transaction, it's not going through. That means the performance is not up to the mark. It has been observed that an additional second of waiting on a website significantly impact customer satisfaction and visitor conversions. Page views drop by 11% or so, conversion rate 7%, and customer satisfaction drops by almost 16%. And how do I get to these numbers? We have certain business cases for this performance testing. I have taken this list from the website, and you can also get over there on Google or maybe any of the internet sites. You can figure out this data. Amazon, if a response time is increased by 100 milliseconds, there's a drop of 1%. Similarly to Yahoo, 400 millisecond gives a drop of 5 to 9% request. Google, 500 millisecond, 20% drop in request. People they shift to other group. Similarly for Bing, Sobzilla, Mozilla, if it has been seen that if the same response time is increased, for example, in negative sense, that is minus 4800 milliseconds, Shopzilla starts behaving fast or Mozilla starts working fast, minus 2200 milliseconds. There's an increase in download, there's an increase in page views, Google Maps reduced the file volume size by 30%, there was an increase in map requests by 30%. Walmart, it decreased its time by 100 milliseconds, and there was a 1% increase in the revenue. What are the performance testing goals? Whenever we do a kind of testing, there is always a goal associated to it. So let's see what are the performance testing goals. To access the production readiness, how ready is our system for production users? Compare two platforms and compare their performance. Which one is performing better? Compare performance characteristics of a system configuration. Depending on the various system configuration, we can figure out which one is working better. Evaluate a system against performance criteria. There are certain criteria which we'll talk about in my upcoming slides. Discover what part of application perform poorly and under what conditions to figure out where your system is failing and what are the bottlenecks. Finding out the source of performance problems. What exactly is the problem to the performance of the system? Until unless you know the problem, you cannot fix it. And supporting system tuning. The system has to be tuned on frequent, regular basis because the external factors keep on changing, but your system should perform the way, at least in a minimum case, your system should perform in a way it was performing earlier. Now let's talk about what are the different types of performance testing. There are a list of performance testing types, but I generally use 5 different types of testing, which are load testing, stress testing, soak or endurance testing, volume or spike testing, and scalability testing. So let's see what is load testing. Load testing is conducted to determine the system behavior under a specific load condition. So let's say, for example, if the number of users are increased till the time it is impacting the CPU utilization, memory consumption, network bandwidth, and the response time. These all scenarios will be covered as a part of load testing. Let's say 100 users, 200 users, 300 users, 400 users, 500 users, and you keep on increasing the number of users, and then you see a difference in the different quality parameters in a due span of time. That is covered as a part of load testing. The other one is stress testing. As a part of stress testing, we do testing beyond the system operational capacity so that to identify when is the system going to break down. In order to find the system bottleneck, performance bottleneck, or the breaking point, stress testing is very useful. We keep on increasing the load till the time system breaks. The third one is endurance or soak testing. The endurance or soak testing is performed with the extended load over a significant extended period of time so as to see how is the system performance behaving. For example, if we have 100 users for 1 hour, 100 users, and you keep on keeping a load or maintaining a load of 100 users for 24 hours, and how exactly is behaving. Fourth kind of performance testing is volume or spike testing, which is conducted to verify a system stability under sudden bounce of load, maybe in form of concurrent users in a very small span of time, and as a result of which you can see spikes. So this is known as spike or volume testing. The fifth one is scalability testing. As a part of scalability testing, we find the capacity of system for being scalable in terms of load supported, transactions, data volume, server capacity, etc. For example, let's say one server or one system under particular server scenario can support 1 million users without any hassle or issues. If you're using 10 servers together, do you think it will support 10 users? No. Theoretically, yes, it should, but practically, when we conduct this testing, we'll see it is support near about a number which is less than 10 million because there are other factors which are also involved in it, and such kind of data is gathered or system performance related issues are known using scalability testing. What are the prerequisites for performance testing? I have mentioned 5 prerequisites over here. First, there should be a stable build. The build should be stable and free from all kind of functional defects. Performance testing environment has to be similar to the production environment. It should be a replica. No other testing should be performed while performance testing is being conducted. And performance testing has to be done just before going live. Means it should be the last testing to be conducted. And the tester who is doing it or the team who is conducting performance testing, they should have a complete understanding and knowledge of application architecture, how it behaves and how it works. Performance test cycle can be divided into 3 major parts. First is run cases, run different kind of cases which are designed and which are supposed to be done so in order to know the performance, collect the data, analyze it, and then depending on this data, optimize your system and again run the process till the time you're satisfied with the performance. How to perform performance testing? So performance testing can be done in following steps which I mentioned over here. First, identify the test environment, identify performance acceptance criteria, plan and design the test cases, configure the test environment, implement the test design, execute your test cases, and analyze, report, and retest till the time you're satisfied with the performance. Let's see the different kind of activities. These mainly include the given activities like identifying test environment. It should be exact replica of the production environment. Identifying the performance acceptance criteria. Friends, acceptance criteria is very important for any kind of testing. In my upcoming videos, I'll let you know the different kind of criteria which we should include as a part of our acceptance criteria. And you should have a testing matrix and acceptable value for the matrix, which should be considered as a part of acceptance criteria. Plan and design the test, configure the test environment, and implementing of the different kind of test designs, scripting user scenarios with the help of performance testing tool. These tools can be load runner or it can be JMeter. I have used these two testing tools for load testing. Executing the test results, executing the test cases in order to generate results. These results are generally a result sheet which is generated after the execution of test cases in form of reports which is then analyzed. It has data points depending on which you have to decide whether your test cases are looking good or not, or are they having the values within the acceptable range. If not, then you do some fine tuning and then do a retest. Let's move on to our next slide. Let's talk about the different kind of performance issues. So first of all, I'd like to discuss web application performance issues. In real-time business scenario, real-time performance testing, you can see some issues like long user time, long user response time, memory leaks, high CPU usage, too many open connections, and the length of the queues for requests, too many table scans for the database deadlocks, error in data returning, HTTPS error, HTTP and HTTPS errors, pages not available. You can have different kind of issues observed in the database performance testing as well, which includes something like insufficient indexing, fragmented database, out of date statistics, faulty application design. So if your design itself is faulty, you'll always have a performance issue. Regarding the web server performance issues, we have basically three kind of issues which are observed. First, high CPU usage, poor server design, and memory leaks or memory problems. With respect to network performance, you can also, while performance testing of the networks, you can observe certain issues with respect to the network performance. It could be because of the firewall throughput or internet access throughput, load balancers, gateways, router. They can also have issues regarding the performance. Application server performance issues. Now, most of the applications they have a connection to the server and then they might be having some performance issues which could be anything out of this four or maybe all of this: poor database tuning, poor cache management, poor session management, poor security design. Now, these were the different kind of issues what we could observe as a part of our performance testing. Let's talk about how to fix these performance issues, how to conduct performance fixes. The first step is to improve current application design by improving the algorithm, caching, DB calls, memory usage. So making different kind of improvements in all this like algo, caching, DB calls, memory uses, we can improve the current application design. Then upgrade the hardware. There should be a matching hardware to the software design. So RAM, CPU, network bandwidth has also to be upgraded. Upgrade the software infrastructure, which is the third step, which includes operating system, web server, databases, and application servers. And last but not the least, upgrade system architecture. The client server basic architecture has to be upgraded to the basic N tier or advanced N tier. Software, hardware changes, use hardware for load balancing, secured layering, and all these different kind of changes. Or maybe architecture related changes could be performed so as to improve the performance. Now, here we are coming to the last slide of our presentation, which is about challenges that could be faced with performance testing. So, here we are having a list of different challenges like infrastructure setup. Infrastructure for performance testing is very important and it is pretty costly. Second, collection and analysis of used data. Now there are different kind of scenarios which are to be tested again and again in different environments using different load and servers and different kind of infrastructure. So it's not an easy thing to maintain, collect and analyze this data. It's a complete huge set of data. Identifying the problem root cause is not an easy thing, but you have to do a lot of analysis on the data in order to identify the root cause of the problem. Most of the time, performance testing is done on the demand of business, but performance testing is a team effort. It requires product vendors, architects, developers, testers, database administrators, and network administrators, everybody to be in sync and work together to identify the best performing solutions for any application or system. Accuracy of result is also very important. Now, there's always a scope, there's a delta or a scope of deviation from the actual result, but how much is the accuracy which you're looking for, that depends on upon your business. Like maybe a rocket system would require a 100% accurate system, 99.99, and maybe a software application running for kids or gaming application, it could be good even if you have 95.5% or 96% accuracy, because it's a huge and if it's a free application, people don't care about the accuracy that much. Client involvement, most of the clients, they are very much interested to know the performance, so clients should also be well aware and informed about the performance testing, its outcomes and challenges, but sometimes it could be pretty annoying for the clients to know that there are certain performance issues, so they are to be handled in a very good way with proper communication. Testing inside the firewall is not an easy thing. With firewall on, system behaves in a totally different way. In firewall off, the system behaves in a totally different manner. Multi-dimensional application like web application, SAS, SaaS, mobile, these have multi-dimensional, multi-platform systems, so they behave in a totally different way. So their coverage and performance testing scenarios to be covered increases manifold. So it has to be covered, and if it is to be done, it will require a lot of effort and time and cost. Testing on live server, it is not an easy thing. When you do testing on live server, you are risking your clients, you are risking your users, so it has to be done in a very sophisticated manner and in a very safe sound manner. And last but not the least, it is pretty expensive. Trust me, friends, it's not easy to do the performance testing. As you have seen, it is one of the most important testing with respect to the non-functional side of application, and it doesn't come so easily. It requires man, material, licenses, people, time, and so much of analysis to be done and then retesting. So we don't do performance testing on day-to-day basis, but as and when required by business, it has to be done. And it is not easy. It is not inexpensive. You have some free tools in the market, but still you need to have the expertise and right people to execute the right kind of test cases and analyze it with respect to the business requirement. Then only it will be fruitful. I hope You'll find this presentation pretty informative and helpful. Do let me know your comments. Thank you. Bye bye.